Here are the notes for box and whisker plots. The very first thing is that we're just going to review the 5 words that we did yesterday in our notes. So the minimum is the lowest number. Okay, we're going to jump to median, which is the middle of the ordered data. So remember, we have to put them in order, so that's why we're going to say the ordered data. Okay, the maximum is the highest number. And then the lower quartile, we're going to use median in its definition. So we know that is going to be the median. We know that as the middle. And since it's called the lower quartile, we know it's the median of the lower half. Now if we know this, the median of the lower half is the lower quartile, then the upper quartile has to be the median of the upper half. And we know that the other name for lower quartile is just Q1, and the upper quartile is Q3. Now this was a review from yesterday. Now this is why it's important, is that this is a box and whisker plot. So the very lowest and the smallest number we know is our min, then our Q1, our median, Q3, and max. And it has to go in that order. Easiest way is it's the smallest number all the way to the biggest number. So if you know the smallest is on the left, the biggest is on the right, the median is in the middle, this is the lower half, and this is the upper half. Now moving on to why they're called quartiles. So quartiles divide a data set into 4 equal parts. Easiest way to remember why it's 4 is that quartiles sound like quarters. So if you can think of quarters, and just like quarters are worth 25 cents, so each quartile contains 25% of the data. So in this section right here is 25%, so from the min to Q1. This section right here is 25%, so Q1 to the median. This next one is 25%, so this is the median to the Q3. And the last one is the max, and this whisker is 25%. So whenever we're looking at specific data, if you look at it, anything below Q3 actually has 3 sections, so that would be 75% of the data. Anything above Q1 is also 75% of the data. Now between the Q1 and Q3 is 50% of the data. So 50% of the data is in the box, 50% of the data is in the whiskers. Now as a review from yesterday, the interquartile range, we know that that is the upper quartile, which is Q3, minus the lower quartile, which is Q1. So when we look in this box right here, we've got how much data is in between these 2 boxes. We've got 50% of the data, since it's 25 in each. And then this whole thing is 100% of the data. Now also with range though, we know that this is 50% of the data, but this also contains the IQR, because this is from Q1 to Q3. Now from the min to the max is 100% of the data, and this is also where the range is. So this little range is the IQR, and the whole range is the range. Okay, moving on to outliers. So this is an extreme value that is much less or much greater than the other data values. So for an example, if we have a data set that is 20, 68, 69, 70, 80, and 200. There are 2 numbers that obviously look like they don't belong. So this 20 looks fairly smaller than the rest of this data. And then this 200 looks way bigger. So that's why the outliers can go to an extreme value on the small side and the big side. So we see 20 looks way too small and 200 looks way too big. The thing about outliers is that outliers have a very strong effect on the mean, and this also affects the mean absolute deviation. Now, the easiest way to notice is that I'm going to take the mean of just the 4 numbers. So off to the side, I'm going to say the mean of the 4 numbers, and then the mean of all 6 numbers together. The mean of the first 4 numbers is 71.75. So if we just look at these 4 numbers, that looks relatively right. So this is the average of these because they all look to be around the same range. Now the mean of these 6 numbers is 84.5. Now if we just had this small outlier, the mean would be much smaller. Now because we have a small one and a big one, this one obviously overpowers it because it's way too big than all the other data. So our mean jumped up significantly. So that's why outliers have a strong effect on the mean. So if it's a very small number, it's going to pull the mean down. And if it has a very big number, it's going to pull the mean up. So that's why it means that they have a very strong effect. Now, to be able to calculate an outlier is because they don't belong in box and whisker plots, is that we have these things called the lower fence and the upper fence. The lower fence is the smallest that the data can be before becoming an outlier. Now you have to remember this formula. Lower fence uses the lower quartile. So lower, lower. And because we're trying to get a lower, that's why we're subtracting. Now this part, you just have to know, is it's always going to be 1.5 times the IQR of the data set. Now the upper fence is the largest the data can be. Now since we're doing the upper fence, we're using the upper quartile, and that's why we're adding. So we're going to use this data set that we have originally, and we're going to find our lower fence and our upper fence to see if they're mathematically that this 20 and this 200 does not belong. So the very first thing you're going to have to do is find the median, and then you're going to find the Q1 and Q3. So go ahead and pause this and find those 3 numbers. The next thing you're going to have to find is the IQR. So you know that that is Q3 minus Q1. So go ahead and find your IQR. Now since we found the median first, so we knew where to split the data, we found Q1, we found Q3, and we found the IQR. So we said 80 minus 68. Now, our lower fence, so we're going to take the lower quartile, which is Q1, so 68, minus 1.5 times our IQR, which is 28. So we're going to go ahead and plug that in a calculator. And we get 26. So again, I'm just plugging exactly what I see in the calculator. Okay, so this is saying the lowest the number can possibly be is 26. Now, do you see any numbers that are less than 26? We see 20. So 20 is less than 26, so we just figured out that 20 actually is an outlier. So 20 is an outlier, and we know this because it's lower than the lowest possible one, which is the lower fence. Now our upper fence is going to be the upper quartile, so Q3. We're adding this one. Still is 28 for the IQR though. So again, we're going to plug that in a calculator. And we get 122. So now this one we have to say, is there any number bigger? So this is saying this is the largest this could possibly be before it becomes an outlier. Well, if we look at our data, again, that 200 that we thought before, yes, it actually is an outlier. So if it's less than the lower fence, or is it smaller than the lower fence, it's an outlier. If it's bigger than the upper fence, then it is an outlier. So now our interval, what this is saying is that all my data, so this is saying X, so all my numbers in my data set need to be between 26 and 122. So all of these numbers in my data should be between these two numbers. If not, in this case, they become outliers. So that's why 20 became an outlier and 200 became an outlier. So go ahead, and on the next example, I want you to find the min, the Q1, median, Q3, max. See if there are any outliers. And to do that, you have to find the IQR. So don't do the number line first. We'll come back to it. Okay, so you should have got your 5 numbers as your 14, 15, 18, 22, 23. Your IQR should have been 7. Your lower fence, so the lowest it could possibly be, is 4.5. Their upper fence, so the highest it could possibly be, is 32.5. Now if we look at it, when we were in order, there's nothing that's lower than 4.5 because our lowest is 14. And there's nothing higher than 32.5 because our biggest number is 23. So in that case, we have no outliers. So because there's nothing smaller and nothing bigger, we have no outliers. So make sure to always check that before you do your box and whisker plot. Now, to actually build the box, we're going to draw 2 dots on our min and our max. So these end our whiskers. So we're going to build our number line. I always start with the lowest number is 14, so that's the first number on my number line. And because I'm trying to go to 23, it's okay if I go by 1, so I have enough space. So now right above this number, 14, we're going to put our dot. And right above 23, another dot. Now on the rest of them, so Q1, median, Q3, we're going to draw a vertical line. So we got vertical line, and a vertical line. So it looks kind of weird, but now we're going to connect our box together. And then attach our whiskers. So we just made a box and whisker plot. So this is how you find a box and whisker plot and how to check for outliers.